this is now about all the rest, right? You have heard about universal theme, the interactive grid, the new create application wizard, and now this session will cover all the rest stuff. And this is basically about two major new features in Application Express 5.2. But before, again, the safe harbor statement. Whatever you see, it might just be a bad dream, right? Whatever is reality, you will see when the product is released. That will be the reality. In the current state, Apex is just like Schrödinger's cat, right? Well, it's in a state of flux. So, whatever. I will talk about two areas, basically. So one is remote SQL, and we will see what exactly that means. And the other one will be generic REST consumption. And I would like first to start with the challenges we are attempting or we are going to solve with Application Express. So what does remote SQL consumption or REST service consumption actually mean? Where are the pitfalls? Where are the special challenges about this? So first about remote SQL. And this is very tightly connected to a feature in the latest and greatest ORTS release. So we are talking about executing SQL statements, queries, DML or pure SQL blocks on a remote Oracle database without using a database link. Right? And the vehicle for this will be ORTS, the latest release 17.3, which is currently available as a beta download, provides that feature. And let me give you a very brief introduction into that feature. It basically consists of a REST endpoint, which receives post requests, and those post requests will accept a JSON, that is the way how it works. So that's a very simple variant of that JSON. So it's one attribute statement text, and we want to select star from tab, and we send that off. Then we get, and that's the interesting bit here, we get a self-describing result set. So first a bit of generic information about the statement we have sent. Then we will see the metadata. In that case we have sent a query. So a query has to be described. And we see the column name, the column type, the precision, the scale, so a bit of information about the data type. And in that case, we have a tname, tab type, and cluster ID. And then after that, we have an items array which contains all the data. So trying that out with another, no. With a good old end table. It also works, and we see the well-known columns of the end table over here. And then comes the items array and containing the actual data. Right? That's, as I said, that's an ORTS feature, and it's the technical foundation to what the ORTS team distributed as well, a JDBC driver based on top of that. So that's when you go to the ORTS webpage, you see the download, then there is also a download for JDBC driver. So you can have a JDBC driver which does not communicate over Oracle's traditional protocol, but which communicates over REST. So that's, so to say, a new protocol to talk to an Oracle database. And the interesting bit, it's based on HTTP, JSON, REST standards, and the goal of this is pretty clear. This is made for today's environments where you have perhaps one database in the cloud, so it's on the internet behind a firewall, the other one is on the intranet, and all these systems have to talk to each other. And a classic database links doesn't make that easier, right? So this is an approach to get these systems together. So the goal or the challenge for Apex then is we want to be able to build Apex components as today on top of SQL queries, but we want to have those SQL queries to be executed on a remote database, not locally as we are used to. Okay. So then, let me show how this works. No. Let me open the browser. And here I have an Application Express instance. And with an expired session. So, and here I have an empty application. We have seen the create app wizard already, so no need to repeat it. And when we go to shared components, there are a few new options in the no, still not really used to the zoom feature. So when you go to the lower left corner, you see the data load definitions that has been there before. And then we now have web source modules. I will come to that later on. And we have ORDS remote databases. So, and that's the feature we are interested in. So let's create one. And you know these dialogues, they are typical for all the shared components. And now we start entering details about that very remote server. And like the ORDS team also did with the JDBC driver, we are doing the same. So the endpoint of that special SQL REST service is typically the ORDS context root, and then you have the schema name, and then you have that _/SQL. And that _/SQL is always the same, so we don't need to enter this. But this is the interesting part, ORDS got. Of course, when somebody sets up their own ORDS instance and have a custom configuration there, the context root could be whatever you like, and also it doesn't necessarily have to be the schema name, right? That you can change all these things in your web server configuration, but that's the typical standard setup. So let's copy that, and that's ORDS. That's my remote SQL. Choose next. Of course, we need authentication, and that's the Scott schema. So the super secret password. I think it was that. And given that, we can create a remote server. It now just has stored the metadata. So basically, as I said, it's the endpoint URL and the credential information. So we are not sure whether this really is correct. So let's test that instance. And that looks good. So we are connected as Scott, and it also prints out the local database timestamp, because that timestamp might be wherever. So when I look at that, it's Pacific time. So that seems to work. So we have a working instance, and if you did something wrong, perhaps have a mistake in the URL, then of course your test will fail, right? So whenever you see a failed here, typically it's three kinds of errors you might will see in that situation: wrong credentials, wrong URL, or when you are using HTTPS, some issues with your wallet and the certificates. But actually, it's pretty straightforward to set this up. So, test again. Good. Okay, now we have created the shared component. Next is actually use it. And I will create, well, let me use that blank page beforehand. Allows me to explain a few things. So we will create a classic report, of course. That is the example we are doing with Apex for 15 years now. So the classic report based on the M table. No. And now when we look into the attribute, into the property editor on the right-hand side of Page Designer, we really see that something will change. You're used to the fact you drag a component on your page, and then on the right-hand side you will enter the SQL query, because all Apex components are driven by SQL queries. And that is, for remote SQL, we have the first change here. We need to tell the Apex component where to execute that SQL query, right? So we need the location. And since we will talk about RESTful services as well, this all goes to the same infrastructure. So our location, our data sources will be local database. That's what we did all the years before. Remote database, that's actually what we are doing now. And web source, that's what I will talk about in 10 minutes. So let's then choose the remote database. And there is another thing we implemented while we were doing this, actually. So you see there is also a type. and that is a SQL query, which you have seen in previous Apex releases or even in the latest in 5.1. And this can now be chosen between SQL query, table of view, or pure SQL function body returning SQL query. And the table/view is new actually. And that means we don't convert a table name to the select star from table anymore. We keep that information that a form has been created on top of just a table, right? You might say, so what, right? Whether from the technical point of view, it doesn't matter whether you execute a select star from table or from or whether you store the table, but actually it's more precise when we store the information that this has been done on a table actually, and it allows us to add additional functionality in the future. So we just have a more detailed declarative metadata storage here. So I will go for a SQL query right now and then choose select star from emp. And now you might have noticed when I tapped out of that field, there was a very short lag, right? So 0.2, 5 seconds, not more. It actually, as always, Page Designer validated that query, of course, but it's a remote database. So Page Designer validated that query remotely. So there was a network. There was a network operation involved, and after that we see, as we are used to, we see all the columns. We might name the region and call it then remote, and we might also apply some formatting. So the hire date column will be, oh, we are in Germany here, come on. And all these things should work rather seamlessly as you are used to it. And you see, this is actually, oh, yeah, I put it into the, where is it? It's not a good idea to put a report into the breadcrumb bar, right? So let's put it into the content body, and we will soon recognize that we can scroll again. So that is better. So doesn't look too spectacular from just viewing the result, but when we think about what we are used to do in Apex, that we are just working on the local database, this is pretty interesting because that data actually comes from another Oracle database without SQLnet, without database links, just HTTP. So that actual Oracle database can be everywhere, in the cloud, outside the cloud, whatever you think about, right? So it's a very flexible way to get data from other, or there will be it's all the future, right? Maybe you wake up tomorrow and it was all a dream, right? Possible. Who knows? Who knows? We might have another look to see, give you a bit of technical background. Let's have a very brief look into the debug log. And this is all the typical stuff. When you scroll down a bit, and here it gets interesting. So it has looked up the remote server, the endpoint URL from our shared components, and it made up the SQL endpoint by appending the /_/SQL. And here we can see it actually did the post request, and with all this VPN and wireless and tunneling from my laptop to that server in the US, that took 0.9 seconds to actually execute that HTTP request, get the data back. And you see it's really not executing SQL, it's really getting out to a remote server and getting the data from there. Okay, we will, the plan is to support that feature in the long run for all Apex components, of course, but not for the next release, right? So we will start with some components and add other components in later on. So the components we we plan to support for 5.2 will be the classic reports. You have seen that. Interactive report, CSS calendar. These do work already in our development system. Charts is also on the list. Forms, interactive grid will most likely have to wait until post 5.2. So you will not be able to use all of this in all components. We will introduce this in phases into Application Express. Okay, so that actually was the first section for remote SQL. So when you look into this from an interactive report point of view, it's really the same as before. The only thing which I might add is that, of course, also the create page wizards will support this. So when we create a report page, and let's now go for interactive report, then we have IR remote SQL.
Carsten, can you please reiterate which components you plan on supporting in 5.2?
That will be the plan is for classic reports, interactive reports, not grid, CSS calendar, and chart. So we add an entry to the menu. And here in that page, traditionally we also entered just a SQL query. Again, when we switch between table or SQL query, again, it stores the explicit information that we are using a table or a view. It doesn't convert to select star from table anymore. And again, we have the remote database. We choose the remote database. And table wizards also target the remote database. So in that case, that Scott user on the remote database has execute privileges on something in the HR schema. And that's the employees table. And again, we can add columns. We might remove a few and create our interactive report, again based on a remote database. And from here, it's just working with an interactive report, right? All the other features, all the actions menu stuff. So it will fire the same SQL it would have used for the local database. It will send the same SQL to the remote database. So from there on, it's pretty much as you are used to Application Express. Okay, any questions about this?
Any reason to still use a database link after this is all implemented?
I think it all depends. So actually, that is HTTP, JSON. And on the other side, we have database links, which is a binary protocol, which is stateful, whereas this one is stateless. So of course there are still reasons to use database links. So I would expect, so when we talk about performance and database links, so the first statement of course is always database links are slow. They have to be slow because we are talking network here, right? But when I compare those two approaches, I'm not measured this, but just from the architectural thing, a database link should be much faster, right? It's binary data. It doesn't have to be marshaled and unmarshaled to and from JSON. And when we're talking about transactions, we have a stateful protocol, which JSON of course isn't, right? So yeah, there are still reasons to use database links. And if you can use database links, I think I would still recommend to use them, right? So if you are still in your same data center and just are about to connect database A, Application Express, to database B, which is just in the rack next to the Apex database, go ahead with database links. But when we're talking about a database in the cloud, you have subscribed to a cloud service. And the data is there. It's not that easy to create a database link to the cloud service. It's technically possible. I heard about customers doing that, but it's never an easy task. You have to involve so many groups. You have to involve your network people. You have to get that tunnel, that SQL net tunnel, over the internet to the cloud provider. So it's really a lot of work. And from that point of view, such a way is much more easy.
Maybe another question is VLOP also supported, so you can also transfer pictures?
No, VLOP is so far not supported. I looked into this, and that's actually ORTS doesn't provide the VLOP to me. So as of now, it's not supported, but I'm pretty sure that's on the list. Okay.
Sorry, one question.
Yeah.
I try to understand the data connection between. So you have a local database, so this is the source.
The source. So Apex is on in that case, and perhaps that makes it transparent. Apex is on this very laptop. There's a Docker image, and it runs the Oracle database with Apex. It's just here. The remote database, that's that machine. Well, that's a machine in the Oracle data center somewhere in DN. That should be Denver. So it's a machine somewhere in Denver in an Oracle data center. And what it's actually doing, it does HTTP requests from my laptop to that machine to Denver.
But it's an ORDS instance.
There is an that's a good point. So the machine in the Denver data center has an ORDS instance in front.
Yeah.
And this has nothing to do. That was a very good question because it reminded me to emphasize on that. That you need an ORDS instance for that, of course, and you need the newest one, ORDS 7. You will need ORDS 17.3 beta. But I think when we will release Apex, this will not be beta anymore. And you need to front-end the database you want to talk to. So the remote database needs to be front-ended by such an ORDS instance to make that REST endpoint available. But this ORDS instance is totally independent from your Apex ORDS instance, which serves your web pages. You could even use that feature when your Apex is front-ended with EPG or even with ModPSQL. It has nothing to do with the Apex listener, ORDS, so to say. Right. Okay, so let's then move on to REST. Right? It's kind of familiar, but for sure a different topic. So the familiar things are that with REST we are also accessing an external system. We are talking HTTP or HTTPS. We are most often talking JSON format, and we are accessing an URL endpoint, and that's where the common things end. With the interesting bit was that with remote SQL we could send any SQL we want, and of course we can't do that with any REST service. So when you have a REST service to integrate, you get an URL endpoint, you get a verb, a method to use, and you get some information about the representation. So you should have some information whether this REST service returns XML, CSV, or JSON. So in these days, it's typically JSON, right? And I have an example for such a RESTful service here. That's a service on top of the emp table. Again, it's JSON. So this service is actually on the same machine in Denver, which the remote SQL instance was on. And that's a RESTful service. So the result sets, the columns, is predefined. The client, we can just invoke that URL and accept the data as it comes. Here is another RESTful service example. That's my favorite earthquake example from the USGS. They have JSON feeds providing earthquake information. And again, you have a URL endpoint, you have a representation, that's JSON in that case, and that JSON feed contains attributes about the earthquakes actually. So that's what we want to integrate with Apex. We can imagine that it will be a matter of JSON parsing, but let's perhaps have another look into a REST service of ORDS. And here comes the fun parts about REST integration. So that's again a REST service based on top of a table in the Oracle database. So the URL is lying actually. So the URL is telling you it's user tab calls. It's all tab calls. I wanted to have rows, right? And and when you have enough rows, you can scroll to the end, and then you see this one. And that's very typical for RESTful services operating on larger amounts of data. So this is done for the web infrastructure, for clients on the web, perhaps even for mobile devices. And it's definitely not recommended to pump millions of rows as the response to an HTTP request. So when you get to RESTful services working on enterprise data, you will most likely encounter this one. So the REST service provides their data in pages, and oh, wait a minute. And to get all the data, you will have to page through this result set. So many RESTful services allow to specify a limit. So I want to have more rows, of course. Thank you. I should know this. Okay, so in that case, I requested 300 rows and I got 300 rows. And now I would get pages of 300. Let's try 700. More. I want to have more. So it should be 700 right now. No, it's 500. Right, that server, that's the, for the odds case, that's the default of 500. So one could, the administrator of the server now could go into the configuration files and increase that number. But from the client, that's, so from the client point of view, that's law for us now, right? We will have to fetch the results in pages. We can get a higher page size up to 500, but that's it. If we want to have 1,000 rows, we need to fetch 2 pages, right? And that's also interesting for filtering. So so I can tell you actually that RESTful service returns about 60,000 rows. So we are interested in all varchar columns. So, or maybe, I have a better idea, maybe the database has some spatial tables, but only a few. We want to see only the spatial tables. So when it's now about filtering, we would have to download all the 60,000 rows and filter on the Oracle side, or in that case, the ORDS REST service allow to pass a filtering syntax with the URL to pass the filter to the server side. And that's where the interesting parts of RESTful integration begin, right? That earthquake example is actually pretty easy because one request, one response, all the data is there, and it's typically a reasonable amount of data. So that's an easy example. Interesting examples are these ones, and that's where we had to work for in Application Express. So that was the introduction to the challenges. Now let's look into how it looks in Apex. Again, let's go to the shared components. And I have 20 minutes, right? Okay, that should work out fine. And we will now visit the other new component, which is web source modules. And we didn't name it web services, we named it web sources, and we wanted it so, right? It wasn't an accident, right? Because it's not necessarily a data feed, it's not necessarily a web service, right? It's that actually tells us we want to get data from the web, right? Whether a purist would agree that this is a web service, whether a purist would agree, yes, this is a REST API, and you can have great discussions about whether something is a REST API or not, or whether it's just a JSON feed, right? We didn't want to go into these definitions and named it generically web sources. So, and web sources come as modules, and we have created a wizard to create such a module, and that module is actually metadata about our external RESTful service. So Apex needs to get some knowledge about this RESTful service, and I would like to start with the earthquake example. So that's simple HTTP. Maybe it's ORDS, but I don't know, right? I don't know the implementation of that, and the only thing I can tell is HTTP does work, so I have to treat this as a simple HTTP service. I provide the URL, the HTTP method is get in that case, and I will click next. And this will, what it always does, it runs forever, because I've forgotten something, I always forget it. This database is in the Oracle intranet. The earthquake example is on the internet. So we need to go to the application definition attributes and add the proxy server. Otherwise, this laptop won't reach the internet. So having done this, do it again. Hit next, and now it should return pretty quick. So now it tried out the URL, so we know that URL is actually working. In the Apex metadata, the endpoint URL is split into a server part and a service part, and that's there for grouping modules belonging to one server together, which makes it easy to change server URLs later on, right? So Apex makes a proposal here. So this Apex assumes, okay, it looks like the server part ends behind feed, and the rest is the service part. You might change it, of course, right? For orts, for instance, the server part could be just server and port. But when I think about that RESTful services are in a specific schema in orts, then the server part in orts would be server port /ort/scott, for instance, right? And /ort/hr would be another server. It's just a grouping of web source modules. I will just accept it. So it might be the case that that service requires authentication, so it works without, but perhaps if I authenticated, I would get the super user view on that data. So in that case, I don't think so. And now let me hit discover. And it will now try to detect the JSON structure. So I've shown you the JSON, and you see a lot of attributes. And what we don't have, that's one of the great differences between REST and SOAP, what we used to use in previous times. SOAP had a description language, the whistle, right? And REST has Swagger, it's developing, but today most of the RESTful services have just unstructured documentation and descriptions. So we have to provide Application Express some information. What attributes actually does that service provide? So, and what Apex does, it fetches the JSON, samples it, and detects columns and data types. And you see a preview on the data here. We see, yeah.
How did you cope with the SSL certificate?
Sorry?
How did you cope with the SSL certificate?
The SSL certificate is just that's a database thing. So I had to work on the wallet in order to make this work. So you have to, when you are working with HTTPS, the technical baseline of this is still UTL HTTP. And to access HTTPS URLs, you need to configure the wallet. And if the wallet doesn't contain the correct root certificates, you have to manually add them. So if you're struggling with this, there is a how-to in the Apex community page. Not that old, it's from June. Apex HTTPS certificates and the wallets. It describes the problem, how you detect the problem, and what you can do, how to best import the certificate. It's all outlined here. So maybe also in other situations a worthwhile read.
That's very good information.
Okay, so you see, we see some column preview. I could see even more details if you're curious. You see also the operations, so it found only a get operation. You could review the JSON if you wish. You can see the response headers. So for the curious guys among us, all the information is there, but we can also just hit create web source and say that looks good. Store all this in the Apex repository. You can have a look into it again. So this is the control central for web source module. You can control every attribute of your web source module, change it and adjust it.
Carsten,
Yeah.
can you go back to authentication? What kind of methods do you support?
So it's currently it's basic authentication and OAuth client credentials. So the client is simple client credentials flow where you can get a client ID, a client secret. It will be exchanged for an access token. No browser redirect, so it's still Apex. It runs in the database. So the interesting part is here the server-to-server communication, and that's what we currently support. We might extend that later on, but not for Apex 5.2. Okay, so the JSON parsing part is reflected in the data profile, and when we look into the JSON, we see that the array of earthquakes is in an attribute named features. That's reflected in the row selector, which is called features. We see the columns. Let's have a look into the magnitude, the strength of the earthquake. It's the selector properties.mag. Properties.mag. And using that dialog, you can always go ahead and change that, add additional columns if you find out that Apex didn't detect something, or if the web service changes, right, and another attribute comes in, you can manually add it, you can change it. What I would like to do, because this is just so many attributes, and I think we won't need most of them, I would just like to hide a few of them. So let me get the magnitude, the place, the time, the title, and the ID, and I would like to hide all the other stuff. So that allows me to set the hidden attribute to false. Save that, and a hidden acts like a hidden column in an Oracle table, right? So it doesn't, it's not being displayed when we create a new component. But if existing components reference these columns, they still work. We just hide it away for new components. So, and that can, of course, we can always change it back to displayed. So, I have to take care on the time.
Carl,
Yeah?
1 second. Are there any entries in the access components?
No. Sure. You need to enable networking access for the Apex engine user, like you need to do today. But it's nothing new compared to existing Application Express versions. So if you have your web service, your Apex web service package working today, it will work with that one the same. Okay, let's create a report, and let me go to an interactive report now. And this is IR USGS. Hit next. Hit next. Menu entry. Hit next. And now we will use the third option of our data sources. We choose a web source, so USGS, and we just see the columns which are not hidden. I want to have all of them. Hit create. And what we now have is an interactive report based on an external JSON feed, right? And we can use all the interactive report features here. Right, we can filter on this. We might highlight them. Well, highlight is in format. So strong, and it's about the mag being greater than, let's say, 2, and the background color should be orange. Apply this, and right. All the features of interactive reports are available. I would now like to create an interactive report based on an ORDS RESTful service. So let's use this one, but without. So that was the ORDS service, which returns all the 60,000 rows in pages. So that's should be an interesting one. Again, go to shared components, web source modules, create the web source modules from scratch. And now we choose ORDS. And ORDS provides some discovery for the HTTP methods. So you see the method select list was hidden when I choose ORDS. I just provide the URL endpoint, and Apex will find out what's there. So again, it's split up to server-specific part. It will again ask me for authentication. I will again be able to discover that. It will now do a bit of ORDS-specific discovery, but the outcome actually won't be too much different from the Earthquake example, because that very ORDS service also provides just the get method, to be honest. So I see the columns, and I hit create web source. So then let's go and create the report. So this is IR on ORDS all tab calls. Hit next. Yes. And again, web source, please. I want to have all the columns, and hit create. Actually, it's pretty quick, right? So again, we see the data from the RESTful service. Again, I will be able to type in audit, for instance, as a row search, and it seems to work. But the interesting part is now, I've told you that REST service returns a 60,000 rows page-wise. So, and it didn't do 120 page requests now. So it must have done something specific to orts, and it's indeed that there is some know-how about an orts RESTful service in Apex, and when looking into the debug log, we will see that. And here is the information what has actually been sent to orts, and you see it's talking about that a JSON filter has been generated, and indeed orts provides a filtering syntax. So when you look up into the orts documentation, there is a chapter about orts filtering grammar, and it will tell you all the details you need to know. But actually, when you create a RESTful service on top of a table or a SQL query, orts allows you to pass filters as your URL parameter. And orts also defined as JSON syntax for these filters. And that syntax is Apex is aware of that syntax, and it translated the end user query into an orts filter. So it actually requested just the right amount of rows from orts. So even if the base amount of rows is so high, it didn't need to fetch all the 60,000 rows. It just passed the filtering to the orts service. And even if the orts service would work on 1 million of rows, if properly indexed on the orts side, and we have a good working filter, then Apex will just get those rows which are really required, and assumed everything is set up correctly. It should be pretty quick also in these cases. One final thing, and for that let me go to the USGS example again. And there is a time component here, and that time component is just a big number, and we all know what this is. What sort of time is that? Unix, right? So that's cool. But in the Oracle world, it's kind of sad, right? Because there is no format mask. So I wish I had to date that number and then a format mask of Unix. But wishing is nice. We just don't have it, right? We have to do something else, and we can do. Let's go again to the data profile. And all this JSON parsing, that's the technical thing behind this, we do all the JSON parsing using SQL functions, right? So we have in 12c, we have the SQL function to parse JSON. In 11g, we don't have it, but in 11g, we have XML parsing. And we can convert JSON to XML very easily. So we can parse it using a SQL function, and the SQL functions provides the parsing results as a table, right? And so when we have this, we can apply all sort of SQL functions on that parsing result. So when having said this, we might add a column, name it time as date. And now it's not a data column. Would be for a data column, I needed to provide a selector, so that's something which comes from the JSON, right? But I can also use a derived column. So, and how was that? That was date. How was that Unix definition? 1970, from January 1st in 1970 plus. So, and now it was those milliseconds since that. So I learned this, and then 3 zeros more. That should work. If not, we will see soon. So let's create that column. And now let me filter out those. So we have the time as date column. And now let's again create one last page for the earthquake example. So use a classic report, classic USGS. Come on. Again, web source. We now have one column more. Let's keep the time column. Run the page. It seems I missed a few zeros. USGS again. So let's walk through the data profile, and I think I think that was right. Yeah.
I didn't see where you referenced the variable to transform that.
To reference the column name. So
Yeah, where was it? Didn't get it.
so
So the original was a numerical value seconds from
milliseconds from January 1st, 1970. Right, that's the definition of the Unix timestamp. It comes in the time column. So
do you reference it there? In your derived column, don't you have to reference the...
I did. I didn't, right? That was it. Right. Thanks a lot for that question.
You're welcome. Now I understand. The question was solution.
Right. So you will get the beer later on. That was the educational effect for you. So that's the formula actually. So, and now when we rerun the page, no, that's wait a moment, that's the earthquakes from one day. So we have to apply a format mask now, but we have a date. Okay? And a date is much better than a Unix timestamp. So we can then do all the fancy stuff we know from Apex. All right, so I want to have it sorted. Right, and that's now it works, correct. So, and the latest one was half an hour ago. So that's basically how that works. That's what we're currently working on and what we plan to release for Apex 5.2. So the basic thing is you will be able to create Apex components. You have seen interactive and classic reports. I didn't show the CSS calendar, but it pretty much works the same way or will work the same way. Charts, we plan to have it working as seamlessly as reports. You will be able to create these components on these remote sources directly. Apex will transparently get the JSON, parse it for you, and you can use these components just as with local SQL. That's how it's supposed to work, and that's all I have right now. Thank you for your attention.